Here's an example. We've got it formulated like this, okay? What are these things here? This is a what? It's a constraint, okay? If you didn't know any decision math language, what else could you call this here? Inequality, okay. What we do in this method, we change it so it's not an inequality. So I'm going to label that one number 1 and that one number 2. Number 1, we change from an inequality into an equality. But we don't just write 3x plus 3y, and I'm deliberately leaving a gap here, equals 120. Because 3x plus 3y could be less than 320. So if it's going to be equal to 320, I'm going to add something else to it. And I add in what's called a slack variable. And for your first slack variable, you usually use the letter S. So basically, if you add something else onto it, then it will be 120. And that thing there, the S, is a slack variable. Have you heard the expression, it's somebody's taking up the slack? It's literally how much sort of play there is in a system, how much spare capacity. And it's linked with that. It's taking up any spare capacity, any excess. So, the first constraint we rewrite like that as an equality. The second one we will also change into an equality. So instead of being 2x plus 4y, and we'll have the 150 over here, what do you think will go in that space? Let's have a guess.
S.
Not going to be S, because that would mean it'd be the same amount as here, and we don't know it's the same amount.
S dash.
Just think alphabet. After S?
T.
T. Okay, yeah. Okay, we just use T for the next one. So here, that T is another slack variable. Okay? So the first thing we've done then is we have changed from 2 inequalities into 2 equalities. Okay? Right, the next thing that we do is we start to rewrite our problem, and we look next at our objective function. Our objective function at the start was this thing here, maximise z, which is 10x plus 12y. Z equals 10x plus 12y. So we're going to change our objective function, because our objective function also needs to include s and t. So we put an s and we put a t in there, but we multiply them by 0. Now, it seems a bit silly, but that's what we do, and you'll see why in a minute. Okay? And you don't really have to understand why, you just have to be able to do it for the time being. Because our constraints now are in terms of x, y and s and t, our decision variables now also in terms of x, y, s and t. So we add no s's, we add no t's. But then each constraint and the objective function have all got in them x, y and s and t. Then what we do, we always rewrite this line here, we always rewrite it so it equals 0. And we always do that by shifting all of this onto the other side of the equation, the equal sign. So, I keep the z where it is, but all of these things I shift to the left. So I'll have a minus 10x, a minus 12y, a minus 0s, and a minus 0t. And then what I do is I write it in a tabular form. So I'm going to write that now in a tabular form, and you do it like this. You have a z column on the left, an x column, a y column, an s column, a t column. That's every letter we've come across so far. We have a value column, and then we have space at the end to make any notes. The top row, underneath that heading row, the top row always corresponds to our objective function. How many z's do you see there, Will Taylor?
1.
Let's write that there. Sam, how many x's do you see here?
-10.
We'll put that there. What do you think the next number in this table is? Anybody? Yeah. -12. Yep. How many s's are here?
What does that say next to the column that we're doing at the moment?
Here.
No, like what's the name of the row that we're doing?
I'll just label that. It's for the objective function. Okay. It's just we're using these numbers here from the objective function to go in here. So it's always a z, one z. It was -10 there, -10 there. How many s's are here? 0. How many t's are in that row? How many t's? Anybody? I don't mind. 0. Okay. And the value is always 0 at this point. So this point here, this is always 0. So we've put one of our objective functions in, well, our one and only objective function in. The next thing we do is put our constraints in, but they're in their equality form. So if we look at the top of the board, there is our first equality. How many z's can you see in that? None. How many x's are there in that? How many x's are there? 3. Y's?
3.
S's? 1. T's? No. Okay. And what's the other number that is there in that one we haven't dealt with yet? 120. That one goes over there. So that was going from that constraint written down as an equality. What do you think? How do you think we're going to write this one down? How is that one going to appear in this row? Just follow the pattern we've just done.
0, 2, 4, 0, 1.
That's exactly right. Yeah. Okay. There were no z's. There were 2 x's, 4 y's, no s's in this one, but there was a t, and we had 150. And when you have it like that, in that state, that is called your initial. Now, for some reason, we don't use the word table, we call them tableaus. Everybody just calls them tableaus. So that is the initial tableau. And if I can remember whether tableau has an X on the end, I could actually label it properly. Does tableau have an X on the end?
It probably does.
So singular doesn't. Then we'll leave it like that, okay?